Alright, so let's solve another example. So this is the differential equation. So you write the matrix form. X prime is equal to 2, 7, negative 1, negative 6, x. So matrix A is really 2, 7, negative 1, negative 6. Now what you want to do is first find the eigenvalues. So pause the video and try to find the eigenvalues by yourself. Okay. Alright, so I will skip finding the eigenvalues part. I will give you the eigenvalues. Lambda 1 is negative 5, lambda 2 is 1. So you want to do it, and if you fail to do it, if you don't know how I get this, the explanation is in the note. This is the example 6 in the note. Okay. Alright, so let's find the eigenvectors, but I will do that. Again, pause the video and find the eigenvectors. Okay. Alright, so to find the eigenvectors, let's check the lambda 1 is equal to negative 5. So A minus, you want to find A minus lambda I, which is A minus minus 5I, which is A plus 5I, which will be 2, 7, negative 1, negative 6 plus 5 times identity, which will be 7, 7, negative 1, negative 1. Now this is what you guess. This is A plus 5y. Now you multiply this by k, little k1, little k2. That is the eigenvector corresponding to negative 5. We want to find that. So multiply the equations. So 7k1 plus 7k2, 0. Negative 1k1, well, negative 1k1 is k1. Negative k1, negative k2 is equal to 0. So is these two equations are same? For a 2 by 2 system, they should be. Okay, they are the same, right? Because you can multiply the second equation by negative 7 and get the first equation. So let's maybe erase the first equation because second equation is much simpler. So from here we can see k1 is negative k2, right? If you take k2 to the other side and multiply by negative. So what would you choose for k2? Let's choose our k2 to be negative 1. So then k1 is 1. So the eigenvector is 1, negative 1. Okay, so that's the eigenvector. Right, let's go to the second eigenvalue. So second eigenvalue is 1. The matrix A is 2, 7, negative 1, negative 6. So you want to find A minus lambda I, which is A minus lambda is 1. So it's A minus I. So let's find A minus I. So 2, 7, negative 1, negative 6 minus I is 1, 0, 0, 1, which is 2 minus 1 is 1, 7 minus 0 is 7, negative 1, negative 6 minus 1 is negative 7. Now you have A minus I here. Now you have multiplied by k1, k2. You want to find this k1 and k2. So let's multiply these rows and see get the two equations. k1 plus 7k2 is equal to 0. Negative k1 minus 7k2 is equal to 0. So these two equations are the same, right? The first equation multiplied by negative 1 get the second equation. So this doesn't matter, right? So k1 is negative 7k2. Choose a number for k2. Let's choose k2 to be 1. Okay, you can choose negative 1 also, doesn't matter. Okay, so then k1 is negative 7, k2 is 1. So that's the second eigenvector. Right, let's write all the information clearly laid out. Lambda 1 is negative 5 and we found its eigenvector to be negative 1, 1. Lambda 2 is 1, its eigenvector is here, negative 7, 1. Now we know we can write the fundamental set of solution. X1 is this eigenvector, negative 1, 1. The relevant eigenvalue is negative 5, e to the negative 5. X2 is negative 7, 1, e to the, this is 1, so e to the lambda is 1. So that's this part of the solution. So the general solution is the linear combination of x1 and x2. So C1 negative 1, 1, e to the negative 5t plus C2 negative 7, 1, e to the t. So this is the general solution for the differential equation, a system of differential equation. Okay, all right. So in next videos I'm gonna do 3 by 3 system. Make sure please you watch them, pause them, and try to do them by yourself and learn. Okay, all right. Thank you. See you in the next video.